Hello. In this video, we're going to continue looking at functions, but we're going to look at functions when you combine them in some interesting ways. So what I want us to do is consider f of x as x squared plus 3x minus 2, and g of x as x squared minus 4x plus 7. And I would like us to determine f of 1 minus g of 1. In other words, I would like us to find f of 1 first, then find g of 1, and then subtract these two values. So let's go ahead here and find f of 1. Remember, this means that everywhere we see an x, we replace it with a 1. So we're going to get 1 squared plus 3 times 1 minus 2. It's going to be 1 plus 3 minus 2, which equals 2. Then we need to find g of 1. That means we get 1 squared minus 4 times 1 plus 7. So that's 1 minus 4 plus 7. That's going to be 4. And finally, we now subtract these two values. So f of 1 is 2. G of 1 is 4. 2 minus 4 is equal to negative 2. All right, let's go ahead and try it again with a different x value. So go ahead and pause the video and give it a try yourself. Find f of 2, find g of 2, and then subtract these two values. All right, so assuming you gave it a try, f of 2 is 2 squared plus 3 times 2 minus 2. So 4 plus 6 minus 2, which is 8. G of 2 is 2 squared minus 4 times 2 plus 7. So 4 minus 8 plus 7, that will be 3. Now we have 8 minus 3. That gives us a total of 5. Okay, so I think we got the hang of it here. We found f of 1 minus g of 1. We found f of 2 minus g of 2. But I want us to take it up a notch. Let's find f of 100 minus g of 100, and we're going to use no calculator. So again, if you need them written down, f of x is still x squared plus 3x minus 2. And g of x is still x squared minus 4x plus 7. So pause the video and give it a try, see what you come up with. Okay, let's do f of 100. That will be 100 squared plus 3 times 100 minus 2. 100 squared is 10,000 plus 300 minus 2. So that's 10,300 minus 2. So 10,298. Okay, let's find g of 100. G of 100 will be 100 squared minus 4 times 100 plus 7. So that's 10,000 minus 400 plus 7. So 9,600 plus 7. 9,607. Okay, so we have 10,298 minus 9,607. That's not going to be doable with mental math. We're probably going to have to stack this. So using our skills of subtraction, we stack it. Then 8 minus 7 is going to be 1. 9 minus 0 is 9. 2 minus 6 we can't do, so we have to borrow. We'll borrow from the 10. 12 minus 6, that will be 6. And 9 minus 9 is 0. So we get 691. Now, hopefully you were able to get all that math worked out, but I mean, if you look at that, you might say to yourself, wow, that's a lot of mental math, that's a lot of arithmetic. I mean, it's doable, sure, but is there some kind of shortcut? Is there some kind of faster way to do this question? And that's what I want to let you think about for a minute. Is there a shortcut for doing f of something minus g of something. As a bit of a hint, does f of x minus g of x, if we don't plug in a number and we just leave it as f of x and g of x, does this have some kind of simplified form? Pause the video and see if you come up with something. All right, so if we plug in f of x here, we'd have x squared plus 3x minus 2. And if we plugged in g of x, we'd have to subtract x squared minus 4x plus 7. Now that negative has to distribute to each one of the terms. So we're going to get x squared plus 3x minus 2 minus x squared plus 4x minus 7. And the x squareds are going to cancel. So we'll have 7x minus 9. Now, if we remember in our last example, x was equal to 100. And if we simply substitute that into our simplified formula, we get 7 times 100 minus 9. So 700 minus 9, which is 691, which just so happens to be our final answer. And if you notice, there was a lot less arithmetic going on here. We were able to do algebra to come up with a simplified formula that was a lot easier to plug in. In fact, we could actually plug in all those values. If you remember, f of 1 minus g of 1 worked out to be negative 2. And we can see that right here. If we have x equal to 1, in our formula 7x minus 9, this becomes 7 times 1 minus 9, which is 7 minus 9, which is negative 2, just like we would expect from over here. And of course, if you plugged in x as 2, you would get 7 times 2 minus 9, which will be 14, minus 9 or 5. So you'll get the same number as before. In fact, we could find f of anything minus g of anything, and this simplified version will help us out a ton. So yes, this definitely works. And what this is here is this is a simplified form for the f of x minus g of x. It's like we've done it one time with algebra, and now whenever we need to plug in an x value, we're good to go. So let's try two different functions. Let's say f of x is 2x squared plus 5x plus 2. G of x is 2x squared plus 4x minus 5. And find f of 100 minus g of 100. You're welcome to plug 100 into both of these and square them and add them and do all the math. Or you're probably better off using the shortcut that we just developed. So go ahead and pause the video and give it a try. All right, so if we do the shortcut, what we do is we first ignore the 100. We ignore x equal to 100. And we just calculate f of x minus g of x, the most general subtraction. We don't subtract specific values, we subtract the functions themselves. So that's going to give us 2x squared plus 5x plus 2 minus 2x squared plus 4x minus 5. Now remember that negative needs to distribute to all of the terms. 2x squared plus 5x plus 2 minus 2x squared minus 4x plus 5. Those are going to cancel, and you'll have x plus 7. Okay, well, this is our general formula for f of x minus g of x. So f of 100 minus g of 100 should just be 100 plus 7, which is 107. Again, we're able to do algebra first, so then when we go to plug in our x value, it's not so bad. Now, I will tell you ahead of time that it doesn't always simplify to such a nice formula. Sometimes it's a little bit more complicated, but the basic idea still holds. Instead of plugging in the 100 first, we can leave it as an x, we can do the subtraction, and then once we have our simplified form, which will always be easier, even if it's not this easy, where it's just x plus 7, it will always be simpler than what we had, and then we can plug in the x. And the fun thing about this is you don't have to just have f of x minus g of x. You can do this for all sorts of different things between the f and the g. For example, we could find f of x plus g of x. So here's an f of x, here's a g of x. Go ahead and pause the video and try adding these two functions. All right, so we have 3x squared minus 4x plus 7. And then we have plus 2x squared minus 11. Well, those x squareds are going to group up to give you 5x squared minus 4x minus 4. And then this over here, this is just notation, f plus g in brackets, and then with a 2 over in another set of brackets. It means the same thing as f of 2 plus g of 2. It's just another way of writing it. You might see this on the worksheet or on some of the reviews. So it's just another way of writing f of 2 plus g of 2. Okay, so that means over here, we need to take that 2 and plug in 2. So we get 5 times 2 squared minus 4 times 2 minus 4. That'll be 5 times 4 minus 8 minus 4. So 20 minus 12, that will be 8. Okay, what if we did multiplication? So we have f of x and we have g of x, and we want to find f of x times g of x. Well, again, we take our f of x, we take our g of x, and we perform whatever operation is between the two functions. In this case, it's multiplication. So go ahead and pause the video and work this out, and then when you're done, find f times g of 1. In other words, with your simplified formula, plug in x equals 1. Okay, so when we FOIL this out, we should get 4x cubed plus 4x squared minus 2x minus 2. And if we plug in here x equal to 1, we're going to get 4 times 1 cubed, 4 times 1 squared, 2 times 1 minus 2. So 4 plus 4 minus 2, that's going to give us 4. In other words, we could say f times g of 1, which is just another way of saying f of 1 times g of 1. This quantity equals 4. And if you wanted, we could go back and do this the old way, right? If we were to find f of 1, this means 4 times 1 squared minus 2. That's going to be 4 minus 2, it's going to be 2. And we could find g of 1. It's going to be 1 plus 1, which is 2. And then we could take these two numbers, 2 times 2, and that's going to give us 4, just like over here. Same. And you might say, well, in this example, maybe it was easier just to plug it in. But it's nice to have this general method and shortcut because, well, it might not always save time. It often does. And in this question, we were actually asked to find the formula, so we kind of had to do both. All right, one more example because we have to look at division. What if we wanted to calculate f of x divided by g of x? Sometimes we write this as f over g of, let's say, 100. So here's f of x, here's g of x, and we need to calculate f divided by g. So again, just as a setup for you, this would look like x squared plus 5x plus 6 divided by x plus 3. So go ahead and pause the video and give it a try to simplify that expression. All right, so hopefully you realize that we could factor this as x plus 3, x plus 2 over x plus 3. That allows us to cancel and simply get x plus 2. So then when we want to find f of g, or f divided by g of 100, that's going to be 100 plus 2, which is just 102. And again, if you were to find it the other way, right, if you were to think of this as f of 100 divided by g of 100, well, you'd have to find f of 100, and f of 100 would be 100 squared plus 5 times 100 plus 6. And I mean, I don't want to do that. And this, I guess, would be 103, right? 100 plus 3, so 103. But now you're going to have to divide some crazy number on the top by 103. I mean, I think this is maybe 10,506 if I work it out quick, but dividing that by 103, my goodness, like that seems like some crazy long division. I don't want to do that. I don't think you want to do that. And in the end, you're just going to get 102 anyways, and we could get it so much quicker by finding this simplified formula. So let's take some notes on this. This new skill we're learning is called function operations. Function operations. And an operation, okay, well, let's look at each word here. Function means f of x or g of x, right? Those are functions. And operations mean addition, subtraction, multiplication, and division. So what we're doing is we're doing the operations, the 4 operations that we know, add, subtract, multiply, and divide, and we're doing them to functions. So for example, we're doing f of x plus, do that in red there, f of x plus g of x. And just so you know, this can be written as f plus g of x. It's like a more compact way of writing it. Now, you might say, well, Mr. Peters, it seems pretty much like the same length. I mean, you've still got an f, you still got a g, you still got an x. But if you notice, in the first example, we only wrote, or in the first example here, we have 2 x's, and by the end, we only have 1 x. So it's actually a little bit shorter. It's a little more compact. And mathematicians always like to try to find ways to save space, to make things more efficient. So even though we've only really lost 1 letter instead of going from f of x, g of x, and now we just have f plus g of x, we've only saved ourselves writing a single x, which might feel insignificant. For a mathematician, any kind of efficiency or cost savings is worth it, because if you're going to write this 10 times, 100 times, 1,000 times, it's nice to just have a very compact version of it. So just so we have them all written down here, f of x minus g of x, another way or a more compact way to write that is f minus g of x. F of x times g of x, we could write as f times g of x. And, oh, we just ran out of space here, but f of x divided by g of x, we'll often write as f over g of x. So let's go ahead and do a quick example. Let's say f of x is 3x minus 5. Let's say g of x is x squared plus 7. Go ahead and find f of x minus g of x. And then also find f minus g of 0. So pause the video and give that a try. All right, so if we do f of x here in blue, 3x minus 5, gx in red minus x squared plus 7. That's going to give us 3x minus 5 minus x squared minus 7. So negative x squared plus 3x minus 12. Now if we plug in 0 to that, we just get 0, 0, negative 12. So the answer would be negative 12. For some more practice, you can try worksheet 2 and 2.5. And then any things to remember, it might be worth noting here that you have to distribute that negative. I always like remembering that this goes to both. That's always a little tricky for students. But otherwise here, we're simply doing our regular rules of functions, but with this extra step of doing an operation first. So we're still doing function evaluation right here at the end, but beforehand, we're doing either subtraction, addition, multiplication, or division with these 2 functions, just to make it a little bit more interesting. All right, hopefully you enjoyed this video, and as always, thanks for watching.